Hello, welcome to Chapter 1, Section 1. This is our first video on our statistics class. So we are going to just do an overview of statistics today. We're going to define a few vocabulary words and then do some practice problems together. So take notes along with me. So the first thing I want to define is statistics, because that's what this class is. So I want to make sure we all understand like what we're doing in this class. So statistics is the science of collecting and organizing, analyzing and interpreting data in order to make decisions. So the whole point of statistics is to be able to make decisions at the end. We want to gather data from people and then kind of study it. What do these people want to do? What patterns or behaviors can we interpret from this? And then we go ahead and make decisions based on that. We throw some math in there, do some calculations, obviously, because this is still a math class. But like the definition says, it is a science. So when we collect data, we want to be looking for information from observations, any counts. So if we just like count how many people like this or whatever, measurements or responses. So far, these are really basic vocabulary words, stuff that you probably already know or have heard before, maybe just not the exact definition. So I wanted to talk about a couple examples just so we can see like what does data look like. So in my first example, I have 70% of the 1,500 US spinal cord injuries to minors result from vehicle accidents, serious business here, and 68% were not wearing a seatbelt. So here, the data that's been collected is whether or not these people have been wearing seatbelts. So this could have happened like in a survey or something like that. So they looked at reports maybe from the vehicle accidents, and they're just trying to see, are these people wearing a seatbelt? Did it result in a spinal cord injury? Because that's pretty bad. So that's an example of data that's been collected. Another example is people who eat 3 daily servings of whole grains have been shown to reduce their risk of stroke by 37%. So again, this is looking at data that's been gathered. So we might have asked them like, do you eat 3 servings of whole grains per day? And then maybe ask them later on, like, did you experience a stroke? And then we can calculate from that, out of all the people that we observed, how many of them actually had a stroke, how many did not, did that reduce their chances of getting a stroke? So these are the things that we're going to be looking into and how to analyze and stuff. So let's actually talk about data sets. When we collect data, obviously we can't ask every single person because like in the world, in Florida, in the city, at a school, that just takes a lot of time. So we want to differentiate between a population and a sample. So population is basically like who you're trying to study. So this is the collection of all the outcomes, all the responses, all the measurements, or all the counts that are of interest to us. So this usually does happen in the US every 10 years. We look at every single person, or we try as hard as we can to look at every single person in the US. So this is actually happening this year in 2020. The census is happening. You might have seen commercials for it. This is where they're trying to gather information from every single person, not just a small group of people. So then a sample, then we only take a part of the population. So the official word is like a subset. So you just want part of the population to be in your sample. And that way you don't have to ask as many people, whatever stuff you're trying to study or research. But since there's less of it, then you kind of leave people out, which is a little bit harder to deal with, but it's much more efficient because there's less work that you have to do. And so statistics is kind of, the whole goal of it is to look at sample data and try to use that to generalize to the whole population. So for example, I said pick a random group of people in the US, gather their information maybe about their like salary, how much they're making, and then, because these are things that usually are asked about in the census, and then use that information to try to predict maybe for that city, for the state, something like that. Instead of asking every single person, because that takes a lot of effort. And that's why the census is only done every 10 years. It takes so much money to actually gather this information. However, that information is really useful because we need to know how many people are exactly living in the city. Because in that city, do we have enough schools? Do we have enough hospitals? Do we have enough roads and infrastructure to support all that's going on within that city with that many people? So that's why we need to know these things, and that's why statistics is so important. Okay, so let's do an example together. We have a recent survey where there's 1,500 adults in the US. They were asked if they thought there was solid evidence for global warming. 855 of the adults said yes. So, identify the population and the sample. So first we need to figure out when these people took the survey, who is the population, who was the sample. So here, it says the survey asked 1,500 adults, okay, in the US. So 1,500 adults in the US were asked, but the population is not those 1,500 adults in the US, because we are talking about this study where they're trying to figure out if like all of the adults in the US believe in global warming or think that there's solid evidence for global warming. So in that case, the population is all adults in the US, not just the 1,500. So you want to look at the words that are describing the type of people. And even if there's like a certain number in it, you want to make sure that that includes everyone when we're talking about a population. So the population is going to be all adults in the US. Which makes the sample those 1,500 adults in the US that were chosen. Okay, so the population is not always going to be explicitly stated in the problem, so you want to be careful of that. Then the second part of the question says, describe the data set. So think about this. When you are asking someone in a survey a question, in which case here they ask, do you think there's solid evidence for global warming? So these people, when they respond, are either going to say yes or no. So when we talk about the data set, our options for like the responses that we could gather is either yes or no. So they told us 855 people answered yes. So that means the rest of the people should have said no. To find that number, we could take the total number of responses, so 1,500 is how many people they asked. If we subtract it from the 855 people who said yes, then we would get all the people who said no. When you subtract 1,500 minus 855, you get 645. So that's going to be our data set. There's 855 people who said yes, and 645 people who said no. So next, couple more vocabulary words is between a parameter and a statistic. So both of these describe a number, but the number depends on like where it came from. So when we talk about like gathering data, those 855 yeses, 645 no's that we just did in the last example, that's data that was gathered to us. That's actually from a statistic. So when you gather data from a sample, the numbers you get out of it or the counts that you get out of it is called a statistic. But if you do it from a population, so like when we take information from the census, for example, those numbers that we get, all of that data gathered, is called parameters. So an easy way to remember this, parameter always goes with a population characteristic. I think of it as both of them start with P's. So P for parameter, P for population. And then sample goes with the statistic. So a statistic is a number that describes a sample characteristic. Okay, so then as we read through problems, stuff you're going to see on the homework is going to be, you have to be able to identify whether the data in there come from a population or from a sample. So is it a parameter or a statistic? So the first example I want to look at is a recent survey of a sample of college career centers reported that the average starting salary for petroleum engineering majors is $83,121. Okay, I mean, this is a solid salary, but they've calculated an average here. So they gathered data, probably asked people like, how much are you making? Or all these engineers, how much are you making? And then they took all of those numbers, averaged it out, and they got this 83,000 something something. So that number here, we want to see if this is a population parameter or a sample statistic. So we want to look at, in this question, did they take that survey from a population or a sample? But if you read carefully, it clearly says sample. They took a sample and then they came up with this number. So that means this has to have been a statistic. So that 83,000 number is a statistic. Okay, example number 2. The 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1442. This is a very solid SAT score. But we've got a few numbers in this question. So we want to make sure we're looking at the right one when we're trying to decide whether it's a parameter or statistic. So first, the 2009 is a year. That's not a statistic or a parameter because it's just describing a fact. It is the year 2009. Okay, so we ignore that one. We're either looking at the 2,182 students or the SAT score of 1442. So really, we're trying to see like what data we gathered. So here, they asked them, they should have been asking like, what was your SAT score? So if that's the question, then the SAT score is going to be the number we're trying to describe as a parameter or a statistic here. So if we look at the 1442, does this number come from a population or a sample? And they said the 2,182 students who accepted admission offers to Northwestern University in 2009, they didn't say anything about like, this is just a part of the people who got accepted in 2009 or anything like that. So this is safe to say that this is from the whole population. Everyone who got accepted to Northwestern University in 2009, this is the average SAT score that they had. So that's how we're going to read whether this is a population or a sample. Okay. Last bit of our notes today. So coming back to what statistics is, we want to look at the different branches of statistics. There are 2, descriptive and inferential. We're going to be doing both this year. We always start off by teaching you guys descriptive statistics because we want to make sure we understand how to like collect the data and describe it. That's what descriptive is. So this is when we're trying to organize, summarize, and display our data. So between this chapter and the next, we're going to learn all the different graphs. That'll help us organize our stuff, make nice visuals for people to understand, and then that also gives people a summary, basically, because once you look at a visual, you're kind of like, oh, this is what's happening. Then once we can do that, then we're going to go into the inferential statistics, where inferential is basically like drawing conclusions. You know how at the beginning we defined statistics as like making decisions? So this is where we're going to draw conclusions and actually make a decision about what our data tells us. Okay, so for our last example, we are looking at a large sample of men aged 48. They were studied for 18 years. So for these unmarried men, approximately 70% were alive at age 65. And for married men, 90% were alive at age 65. So we want to see which part of this study represents the descriptive branch of statistics. So basically, what are they describing? So here, the description part is really just what data did they gather from this study. So they told us that they looked at these people, age 48, for 18 years, and at the end, after they asked them about their lives, whatever, they found that 70% were alive at age 65, 90% were alive at age 65. So the descriptive side is really just taking the numbers that you gathered and just like, it's kind of like stating facts. There's no opinion involved. There's no conclusions involved. You're just saying, this is the data that I got. So when they ask about the descriptive branch of statistics, we're just saying that 70% of unmarried men were alive at age 65. And then that 90% were alive of the married men were alive at age 65. Okay, so just the observations that you got from your data, no conclusions, no interpretations. So the next question is, what conclusions might be drawn from the study using inferential statistics? So now we actually get to make a conclusion. So just looking at the numbers, it kind of looks like if you're unmarried, you're not going to live as long. Because, I mean, there's less of them that were alive when they were age 65. So not great news. But so maybe one of the conclusions we might say is that married men live longer. But this is a very broad statement. I don't know if you realize this, because looking out into the world, I don't know about you, but married men, sometimes they don't seem like they would live longer. I don't know. Are there other reasons? Can we say this, like, this conclusion just based on these numbers? I'm going to go with, I don't know if this is exactly true. I don't know if marriage actually causes men to live longer. So I'm going to reword it like this because I want to make my statement or my conclusion for my inferential statistics as accurate as possible. So I'm going to say, instead of married men live longer, maybe married men, or actually, let me go with like marriage. Is associated with a longer life. Because I don't know if I can exactly say marriage causes you to live longer, but when I say associated, this is kind of more just saying like there's a pattern, there's a trend here that I see. So I don't know if this is exactly why people live longer. Being married might be a reason, but it's not the cause, I don't think. So that's how we want to be careful when we word our stuff. So because, you know, married people, I'm hoping that they're happier. And happier people usually tend to live longer because, you know, they're less stressed and maybe have healthier habits because married people would encourage each other to be better versions of themselves, stuff like that. So we don't want to exactly say that one causes the other, but we can say that there's a pattern, or this is something that we observed, and so this is the conclusion that we could potentially draw from it. So I'm just going to add in the notes that associated just means there's a pattern or trend of this happening. But yeah. that's it for section 1, guys. Thanks for watching. Bye.